Hello friends, welcome to this video series, and in this video series we are going to learn about Numpy. We are going to start from its basic concepts like creating arrays, and we will cover all its advanced concepts. So this is going to first video of this series, and in this first video we are going to learn how to create these Numpy arrays. Then we are going to perform indexing and slicing operation on these Numpy arrays. So first the question arises is, what is Numpy? So Numpy is an open source library for the scientific computing in Python. It provides you with the high performance multi-dimensional array objects called ND array. So ND array refers to as the n dimensional array. So with the help of this Numpy library you can create n dimensional array. It provides you with a large collection of functions to operate on these array. It is used in image processing, signal processing, linear algebra, and much more places. And it is the most fundamental library for the data science. Now first of all we are going to import this Numpy library. Import Numpy as np. So we have imported. Now we are going to start by creating one dimensional array. Then we go for its 2 dimension and 3 dimension. Now first create a heading for 1 dimension. I make it a mark code. It's heading. Now let's create a 1 dimensional array using the numpy np.array function. We are going to give the data in a from a list 1, 2 and 3. Next we need to specify the data using this d type np.int16. Now let's print this 1 dimensional array. Next we are going to print its type using the type function available in the Python. Now let's run it. So you can see we have first print this variable, that is numpy array, and we have the same information which inserted in the list with the type numpy, that is integer 16, and the type is numpy.nd array. So nd array refers to n dimensional array. Okay, now this is a simple 1 dimensional numpy array. They are going to perform indexing on it. So indexing basically refers to accessing the individual elements. Basically we are referring to the index number. So here we have 3 elements. So we have size of this is 3. So indexing always means 0. So if, let me just do it practically. First, for indexing in the Python, first write the numpy variable name, not numpy, any variable, just in reference we are talking about numpy. So we'll consider x, then square bracket, and then the index number 0. Indexing always begins with 0. So 0 refers to the first element, that is 1. After that we'll do the same, print x square bracket, then 1, and next we'll x 2. So we have these 3 elements and we have put in 3 indexes number 0, 1, 2, and to run it. So you can see we have 3 elements printed, 1, 2 and 3. So that's how you perform indexing in forward order. But you can also perform sequencing in reverse order. Like if you want to access the last element and you don't know what the size of the list is, regardless of the size, you can simply write the variable name with square bracket, and then instead of writing 0 you write -1. So -1 refer to the last element, and this series goes on. Like if you write x -2, so this is second last element, and -3 the third last element. Okay, -3 of x, so it should be like this. So you can see now we have accessed the list in the reverse order, -1, -2, -3, same order. Okay, now let me just do one more thing. If I write like x3, so what will happen? So we have got an index error, index 3 is out of bound. So this error because the index 3 does not exist in this numpy array. It only has 3 elements, so index's number must be 3 minus 1, so 2. Index, the last index is 2, 0, 1, 2. So that's why we got this index error. Same thing we got if we access index element in reverse order. Like if I put -4 here, so -4 index position doesn't exist because number of elements are less. That's why. So that's why we got this error. Now we are going to move to this 2 dimensional array. This is for the 1 dimensional. Now let's move to 2 dimensional. Now we'll use the same variable name and create the same function np.array. Now again using the list 1, 2, 3, close this. Second list 4, 5, 6. Okay. Now specifying the type the data, and again integer 16. So now I'm going to print it. So we have this two-dimensional numpy array and having the element 1, 2 and 3, 4, 5, 6. So it's having 2 rows, okay, and 3 columns. Now we're going to perform indexing on this two-dimension array, that is x two-dimension array. First of all, it's two-dimension. Now we specify two indexes, two index number, first for the row and second for the column. So again the print variable name in square bracket. Now first specify the row number. So row number is 0, that is this row 1, 2, 3. Next a comma and then specify the column number. So column number 0. So first row, first column. So element should print 1. Like this we are going to print the entire row x 0 1, print x 0 2. Now we will print this and we will see 1, 2 and 3. So you can see we have got all the elements from the first row or the 0th index row. Now we can do the same with the second row, just changing the row number, row index position, same. Now we're going to see 4, 5 and 6 printed on the screen. So you can see this is how we access the elements in a two-dimension array. Now in a two-dimension array we can also slice these arrays to create sub-arrays. Here we are going to see the slicing part. Simply just print the variable name and again the square bracket. First, if you just want to get the first column, entire first column, so you know that first here refers to the row and then second portion refers to the column. Same concept is here. So if I put this column here, this means entire row, and specify a comma for the next for the column. So the 0th column. So what should I get? Entire row. Okay, all rows should be considered, but only 0th column number should be there. So it should get 1, 4. This is what I believe. So you can see we have got 1, 4. So like this you can access all the other, like if I just write 1 here and again just copy this here and so we're going to get 2, 5 and 3, 6. So let's see. So you can see 2, 5, 3, 6. That's how you slice these two-dimension array to create an one-dimension array. So here within these two-dimension array we have extracted each sub-array, slice them and get one-dimension array. Like this you can also print the values of the second row. That means copy this. Okay. Now let's change some values here. If we just now currently we are printing with the first this, now in this 1, 4, 2, 5, 3, 6. Now let's just print some different value. If instead of just specifying the column number, we can also specify the row number. Like if we want to print the first row, that is index position 1, or the second row, we can also say that print all the columns at the row 1. Same we can do here. Row number should be 1 and column should be all. So you can see 4, 5, 6, 4, 5, 6. It should be same because with everything written the same. Okay, now just change it, do it like this. So you can see if row number is 0 and we're going to print all the columns, so we get 1, 2, 3. This is the row 0 and all the columns, the 3 columns. So all the values of columns are printed 1, 2, 3. Row 1 and all the values of columns will be printed. So 4, 5, 6. So that's how you slice these arrays. It's a bit tricky, just a little bit. Just take time and understand it. No problem. We're gonna get. Now we're gonna get to the 3-dimension array. Create another markdown. Okay. Now let's create a 3-dimension array. Now you need to be see it. It can be a bit confusing. Okay, now let's separate this 1, 2 and 3. Okay. Now 4 5 6. Now it's a bit tricky. Zero, -1, -2. Okay. And one more list, -3, -4, -5. Okay. That is, now we have created a three-dimensional. It's a little confusing. Now we need to specify data type, same, np.int16. Okay, now we're going to print this list and hope we don't get any error. So we can see we have a three-dimensional list, a three-dimensional numpy array, not a list. Okay, we're basically using a list to create numpy array. So the three-dimensional numpy array. Now again indexing first, again same thing. Now three-dimensional array, so 3 index position. Now if I specify 0, 0, 0, what should I get? I should get 1. So you can see I have got 1. Now just imagine again indexing. If you just specify the index position that is out of bound, you get an error. Just like C here, specify 0, 0, 3. I should get error. Yeah, I should get error because index 3 is out of bound. So now let me just print some more values. Like if I just have 0, 1, 0, 0, 3, not 3 as an, let's print this into and see. We have got, oh, I should put the X here, my mistake. So I've got the value 3 here, 0, 0, 2. So this 3 here we have got this value. From this 0, this 0, this is the 0. Let me just put it here. This is a 0, then this is a 1. Okay, now again 0. Now from this is the 0 and this is 2. 1, 0, 1, 2. So that's how we got this 3. I hope you actually get it. Again we can do the same thing. X, this time 1 specify. So 1 is going to be from this entire two-dimensional array. Then specify one more 1 here. So now from this is going to the next one and specify like 2 here. So I should get -4. No, -2, it should be -5 because 0, 1, 2. I should get -5. So you can see I've got -5. So that's how you index a three-dimensional array. Now let's perform some slicing operation. You can print X, same. Just we're going to print everything from the first axis, everything was second, and now the 0th. So what should we get? Let me just print it. -4, 0, 3. Okay, so again we get -4, 1, 4, 0, 3. So how we get this? So everything from this first and this second. Okay, now then everything from this. Okay, now it's a bit confusing. Let me just try one more simple example, just where we specify something, not that much. First should be everything, then specify 0, 0. Let's just do this. You see we get 1 and 0. Okay. So 0, 0 from every position. So this is 0, 0, this is 0, 0. That's how we got this slicing. So when you just increase these dimensions, it get more confusing, and you can see in 3 dimensions we are still little confused, but you won't get this condition because you don't need to just do this thing. There are many already available functions which you can use. This is just to show you how you can perform these slicing. So what are these basic things? How can you create these arrays, perform indexing and slicing on this thing? So I hope you all get the concept and learn how to create these indexing, perform how to create these numpy arrays, then perform indexing and slicing on these arrays. So thank you for watching this video. If you have any query, comment below. Thank you. Have a nice day.